All right, this is the final part of our lesson on having our front end talk to our back end. And we covered how to create a JavaScript request. And let's actually take a quick look at our architecture diagram here to refresh ourselves on what we're doing. And let's kind of just bring it all in so it all fits in one screen. And let's bring our server and database a little closer. And that's probably close enough. I'll zoom out just a little bit just to give us some room here. Okay, that'll do the job. So, um, we have a full stack application. I've got my browser with my JavaScript running in it. Over here, we have a server. So far, we've been using the Poke API server that's somewhere on the internet, but in a minute, we'll replace this with our Flask server. And we can assume that we don't actually know that the Poke API server talks to some database where all the Pokemon information is stored. And what we went over was writing some JavaScript code to make an HTTP request to this server, to this REST API, to fetch data. So we have to send the request, and that takes time, right? It takes a couple milliseconds at least to go over the internet to the server. I don't know how long it'll take. Then the server's got to talk to the database. The database has to send the information back. Maybe the server's handling multiple requests. It serializes the data and returns it. And as we saw, JavaScript doesn't actually stop and wait for this response to come back. The JavaScript code keeps running. And so to deal with that, we use this construct called a promise. And so we use a promise to fetch the data. The JavaScript code keeps running, but then when the response is sent back, the promise is fulfilled, right? And at that point, we receive the response and we format the data, and then we can use it to create a card or add something to our user interface to render that data to the DOM. And we were reviewing that a little bit as well, too, where I want to build a Pokemon card that looks like this, where we're using our JSON data, right, for the name of our Pokemon and to get that image URL so we can show an image. And we've got a container div and an image element and an H5 header element. And then we're actually going to add that container to our HTML document, right? And in fact, we might end up with multiple of these. And we wrote some code to accomplish this task successfully. And just to very quickly pull up that JavaScript code, I have a get Pokemon method. I give it a Pokemon name. I use fetch that's going to make my API call to the REST API. And then because this is a promise, we have to tell JavaScript what it should do once the response comes back. And when we get back the HTTP response, it's not just the JSON data, it's a whole bunch of response headers and other information. So we need to tell JavaScript that we only want the JSON in the response body. And then we can chain another .then as part of the promise that then takes this Pokemon JSON data. And now we can really do our work with it. And so here I'm grabbing the information that I care about, the Pokemon's name, its sprite, I'm printing it out. But really I'm just going to pass all the data into this other function that we wrote, create Pokemon card. Right, so I'm calling get Pokemon, we're looking for Ditto. It fetches the data, and then we're taking all that Pokemon data and passing it into create Pokemon card. And there's a lot of console logs here, but the goal is pretty straightforward. We grab the data we want from the JSON. We create the elements we need for our card. We add the data to the card. We add the elements to the card so that they're all together, right? And then we attach that card to its container in the DOM. And if I go back to my index.html, we have this Pokemon card container here that this card is getting put in. And so when I run my code, and let's make sure this live server is still live, and it is, we see a bunch of things printed out, and we've grabbed Ditto, and we have this card here that is now inside our container. And I have the Pokemon container for all the cards, and then the card that I created, though I need to mess with the CSS as the sprite is sort of overflowing, but we have our container and Ditto and the image sprite. And I just want to check in to see if folks have any questions. Rick, yes, or Chris, yes, sir.
First off, thanks for the additional comments on the for each of the code that you have there. Um, I noticed you had a few decorators that I didn't notice before. I think it was like at param and returns.
Oh, that's a great point. So this is the same syntax as a decorator, but in JavaScript, and because this is inside a comment block, this is actually just a comment. The reason the VS Code highlights it and formats it funny is because this is what's called JS documentation. And it's a way that you can, like, it's sort of like a standardized way of documenting functions. So this is actually all just a comment, but because it's standardized and structured, VS Code will notice it. And like if I hover over create PokeCard, see how it's using my comment block. So this is a good practice. I don't want folks to get too tied up on this because writing the code is the most important thing. But since there was some feedback around documenting and making code clearer, I figured this would be good to see. Python has a different way of doing this. Each language kind of has its own commenting documentation standard. Yeah, thank you for asking. Great question. The one thing I want to do with this before we switch gears and write some very similar code that's going to talk to our Flask server is it'd be nice if we could manually enter the name of the Pokemon we want to get and click a button to call this code. So over here for our get Pokemon, I'm going to create a form. And inside that form, I'm going to add an input field. And I'm just going to give it a name and we'll just call it Pokemon name. And we'll give it a placeholder. We'll say enter Poke name. And we'll close out my input tag. And let's make sure that that's working. Yep. And let's put this outside of the container. And now let's add a button. And it's going to be a submit button. And on click, we are going to call the get Pokemon function. Though we do have to modify this a bit to grab the name from the input field. So that's going to be our next task. And we should add some text here to the button. So it renders. And I can check now to make sure this button's hooked up. And indeed, I see it's calling and it's getting Ditto. It doesn't matter what Pokemon I put in here. But that's okay. We're breaking this down into steps. And right, step one was create the input elements. Step two was connect the button to the function I want to call. Uh, and in fact, let's not call get Pokemon directly. Let's make a handler function. And this is a really common path that you'll see. And we'll call this handle get Pokemon. Because there's a couple things we need to do in here. I don't like that when I was clicking get Pokemon, the whole page was refreshing, among other things. So up here, let's create a new function. We're going to call it handle get Pokemon. And its job is going to be get the Poke name from the input field in the form and use it to fetch the Poke data and render it. And it will take in an event as an argument. And I'm just going to add a console log here that says handle get Pokemon. And I know that I want to stop the form's default behavior of refreshing the page. So let's add those things and let's make sure that that works. And I think we're still refreshing here. So let's see here. I may have made a typo or an error in my code. I think it would help, first of all, if I passed in the event as an argument, which we probably need. And for consistency, let's just use the same variable name. And now I think prevent default should work. I don't think I was passing this in before, and so the prevent default was getting called on null. Yep, and now we see the page is not refreshing. So that's what we want. And now that I've done this, we've got to get the data from the form. And there's a couple steps here to that. And let's just kind of combine it all in one go. I need to, I'm going to be grabbing the data from the form and then also turning it into an object to make it easy to work with. So in a perfect world, maybe this wouldn't be one line of code, but it's a little more succinct this way. And it should be working. And now if I console log data opt, and this is sort of my version of informal test-driven development, is I just console log everything. And I see that I have an error where I did something wrong. So let's see where our mistake was. And I feel like I probably got ahead of myself by adding all this code on one line. So let's break this into 2 lines. And then let's console.log form data. And I think I also know where my bug is. But let's run this and see what happens, and then we'll go look at what I suspect my other error may have been. So I can see here, this code looks right, but it still doesn't seem to be going in there. So I want to go back to my form and double check how I wrote it. And I kind of combined 2 styles, and that's what's causing the problem. I put the on click here on the button. And if I don't want to use a form element at all, this is kind of how I would do it. And then I would have to grab the input element. When I'm using a form, instead of on click, I believe what I want to do and where I ran into my issue was I want form on submit. And so the function gets called from here, and the browser does the work of grabbing whatever input fields I have in here and bundling them up into the event that gets passed in here. And I'm just going to make sure I have my name right. And now if we try this, let's see what happens. And now we're seeing what we expected, right? So this is kind of a simple kind of error to make. And I think the key thing to remember is if I'm going to use a form element, my handler function needs to be in the on submit, not called directly from the button on click, because this way the browser will grab all these input fields and bundle them up and pass them in this event object. And let me get rid of some of these console logs that I no longer need. And now we can call our get Pokemon function, and we can pass in as an argument, it should be data object dot Pokemon dash name. And in fact, I think I'm going to change this to something simpler because I'm not sure JavaScript likes the dash in the object key name. I feel like that gave me a problem the other day, and simpler is better. So let's run this now and see how we do. If I type in Charmander, do I get Charmander? And indeed, we now have Charmander, and I can grab Pikachu and Eevee, if I'm spelling their name right, and maybe even Squirtle. And then if I refresh the page, they're all gone except for Ditto. And the only reason Ditto is loading is because all the way down here, I'm manually calling that. So if I comment that out, it refreshes and now there's no one there. So I just want to pause and check in here and see what questions people have or what's on people's minds. Because I know we saw some of this yesterday, but it's still fresh and we're seeing it in a new context. We feeling pretty good about this code? Rick, yes, sir.
Yeah, I'm just curious. You mentioned that whenever you refresh the page, it goes away. So is there like a way to write it to something so that when the page refreshes, it doesn't go away?
Yeah, that's a great question. The short answer is no, it's not possible. This is sort of the curse of JavaScript running in the browser. It's like when I run a program from the command line, if I did node main.js or, Python main.py, whatever variables get created in memory when my program runs disappear when I stop my program. The long answer is that's why storing data that we care about in a database is so important so that we can fetch it from there. If we go back to our diagram, I have a couple of these diagrams. That's the one I want. Where when I'm building a web application and a full stack app, it's really important for the database to be the source of truth. There's ways to cache things on the browser as well, but it gets more complex and there are more edge cases. We'll learn about it later, but even then, the source of truth is always sort of the database on the back end because what if, Pokemon data changes and we need to fetch the new Pokemon? Yeah, great
So
question.
yeah, so you could actually make like some kind of a table in your database that says like current browser config or whatever, so that when you reloaded it you could do like an if statement, if pull from the database first and then fill in the information, and then if the user enters more Pokemon, continue to add them. All right, got it. Yep.
Yeah. And some of that we can put in code too. Like I can write my code so that every time the page is loaded, maybe I do want to fetch a Pokemon by default, right? Maybe we decide we always want to see Ditto. And so I can put that in code as well if I want to do it that way. Tom, yes, sir.
Going back to fetching the data from your form, you're turning it into an object. If there's multiple um, points of data entry, I would get that. But is there any particular reason why you're doing that if we're just entering like that one input field?
Oh, let me unmute myself. Yeah, good question. The way that HTML forms in the browser works, whether I have one input field or three, it still forms this sort of object-like thing. Um, so it's sort of like, I get a dictionary, whether there's one thing or 10 things. It always does the same structure. So I still need to take this and turn it into an object so I can grab this property. And Tony, yes, sir, I think you had a question as well.
Sorry, I was muted too. Rick took care of it on the second back into his question, so I'm good.
Awesome. Yeah, there's ways to store stuff on the browser. Cookies are one way to store things as well. But in general, and especially getting started, thinking of the database as the source of truth is really important in terms of data. And with front end apps, the page refresh is a constant concern. Like, let's see, if I go to Amazon and I type in cats and I refresh the page, cats is gone, right? Now, maybe if Amazon really cared, they could have saved that, but to some degree, having sort of information be ephemeral in the front end is part of the deal with the web. Let's see, in fact, talking about putting data in the back end, let's do another version of this, but this time instead of the Pokey API, we're going to work with our school Flask database, right? And so now our server is our Flask server, right? Which is our API. And we're going to use the student model that we created, and we'll take a look at that code in just a sec. And that's talking to our database that has that student table in it. And in this case, our server is not running on a different computer, it's running on our computer, right? And so I still have a client server architecture with the client, with my browser and my server and a database. But in this case, they're all running on the same machine. And just to refresh ourselves on the structure of what we put together, and let me pull up the terminal here just a touch. If we start with the database, and do we have the SQL here? We do. We made a students table. And so if I go into pSQL and connect to my school database, we had previously loaded about 5 students in there. And we had a table of students with the first name, last name, grade, and so on. And then what we saw to do was write a Flask server, right? And connect it to that database. And then create a special kind of class called a model so that we can use Python OOP code to talk to that students table in the database. And when we get back an instance of a student from the database, turn it into a dictionary so we can send it to our browser. And then we wrote an endpoint, and we spent a lot of time today really digging into HTTP and REST API conventions. And now we kind of see in action again what we wrote the other day, where we have this endpoint get students just for fun. We get the count, but the important thing is we make a query to get all of the students from the database, and then we serialize those objects and turn them into dictionaries and turn that into JSON so I can send it back to my browser. And so now I do have to run my Python server, and it's in a directory named server. And so now our Python API is running. and it's running on my local host on port 8000. And if I go here in the browser, we can go to /API/v1/students, and we get the students back. And this is great, but what I want to do now is write some JavaScript code that will do this for me. Alex, yes, sir.
So when we create this Flash server, if I were to type in that exact URL that you just typed in, would I be able to access it from my computer?
That's a great question. You should be able to, yes, because this IP address 127.0.0.1 is a special one that by convention always represents my own computer or my own local network. And in fact, if I use localhost instead of the IP address, Flask seems to, oh, no. This is Django REST framework. I have something else. I have something else running on this port is what's going on here. So I will give me just a moment here to kill the other server that I have running. If I can just remember the command that I want. I think we'll be okay as long as I stick with 127.0.0.1. Because localhost seems to be set up to go somewhere. I think, in fact, what I'll do is I'm going to change this port to 8888 just to be safe. I think you all have this as 8000 in your code. But this way, hopefully, I should avoid any conflicts with the Django server that I have running. Rick, yes, sir.
Yes, a question. So I understand that you put your HTML in the route. All right. Is there a way besides using templates to just insert a HTML document? So instead of actually writing out the code, you have your HTML saved in a separate location and you pass it to the app route. So then it loads the HTML page. The only way I could find was templates. Is there any other way that you know of? Instead of
Templates is the
writing out your
normal.
code.
Templates
Yeah.
is normally how you would do that.
Okay.
Yeah, and we're doing something slightly different because you touch on a good point. I have 3 things running right now, and this is a little different from our ports diagram, but I think this is good for folks to see. So actually, I'm glad you mentioned this. I have live server, and live server is, let's call this the front end server, and it's serving index.html to my browser. And really, I guess we could say I actually have 4 things running. And let's maybe move this up here a bit, or we'll just sort of navigate down. So I have live server. And then over here, I also have my browser. And this is all running on my computer, on my local network, right? So think about those sort of the diagram with all the ports that we saw before. And this is a common pattern. Later, we'll see how to use a different server for the front end instead of live server. But right now, live server is just the simplest. And we have our Postgres DB, right? And this is port 5432. Live server is, what port is live server on? Port 5500. And then I have my Flask API server, my REST API, running on port 8888. And so what's actually happening here is my browser talks to live server. Live server sends back several things. It sends back index.html, right? And it also sends back my JavaScript and my CSS file. And then here in the browser, I actually have the HTML. And I also have the JS running here in the browser. And then what we're going to do, and this was how we had it before, except it wasn't my Flask API server, it was the Pokey API server. But what we're about to do now is the JavaScript makes that HTTP request to my Flask server, right? And then the Flask server talks to the database and sends back data. And then data is sent back to the browser. And I realize this is a little off topic from what you were saying, Rich, but you're correct that one way of doing things is you construct HTML files or you have templates that are here from the server. But this approach, or that's over here, but this approach that we're seeing now is sort of an approach where I have a server whose only job is to be a REST API, right? Like the beauty of the Pokey API is that it doesn't care if it's talking to my browser, my JavaScript code, curl, or anything else. Its only job is to give me data and maybe work with that data. And this is a really powerful pattern. And so the job of our Flask REST API server is to talk to the database to create, read, update, or delete data, and then send that back data to whatever client wants it. And then it's the job of the JavaScript running in my browser to turn that data into HTML that we put on the DOM. And so kind of building off of this, let's actually start writing out some of this code. And let me pull up my guide code real quick to make sure that I'm on the right path here. So we have to do a similar pattern. And hopefully, does this help answer some of the questions that you guys had just to check in? Yes, no, maybe. Awesome. I see a couple thumbs up. Thank you. Yeah, this is good. And when we get to React.js, we'll see that it is doing a lot of the work of creating what we have running here in the browser. And we end up writing a lot of JavaScript code, and we end up writing very little HTML. So to write the JavaScript that I need to talk to my Flask server, we're going to write a function that gets the students from the Flask server. So we're going to need to make a, get students request. We're going to need to use a promise to handle the asynchronous HTTP request. We're going to need to then format the response data into JSON. And we're going to need to do something with that data, right? We are going to then render the student data to the DOM. So I'm going to write a function called getStudents. And I'm going to write this one differently. There are two ways to make a promise. The way that you guys saw with .then is sort of the older way, but still a good way. But the way that we're going to do now uses something called async await, which is a newer style or syntactic sugar for writing promises. And both work perfectly fine. I think most people find this style easier to write, and we'll have a lot of experience to work with both when we get into the React front-end module. So I have to use this special keyword async in front of my arrow function. And then I'm going to use the keyword await. And this tells JavaScript to wait until the promise is resolved. So I say await fetch, and now I need to pass in the IP address, and this is my local machine and the port my code is running on. So for me, this is a little different because I changed it to 8888. For most of you, it's 8000. And then the URI to the resource, right? And there's no file here, but my Python server knows that this represents the list of all the students, and to call that get students view function or endpoint that we wrote. And once I've done that, I need to get the JSON from the response. And so instead of those .thens, I need to say await, right, for each sort of step of the promise or the asynchronous operation, because this depends on the HTTP request, and this depends on that. And so this one needs to wait on that one, and this one needs to wait on the API call. But now that I've gotten this, we're done waiting, and JavaScript will make sure not to go past await until the promise is resolved, which is what we call when it's done. So now I can safely write code like normal. And I'm going to write a for loop if I can spell things out correctly. And let's just start. We know we're going to want to maybe add student info to a list, right, in the DOM. But let's just start by console logging the student to make sure that this code is working correctly. And so let me go over here and refresh the server. And it would sure help if I actually called this get students function after doing all this work of writing it. So let's go ahead and call our function. And now we do see an error, uncaught in promise, failed to fetch. And we see a really interesting error message here. Access to fetch, blah, 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 has been blocked by CORS policy. Now, we're going to learn about what CORS is later. It stands for Cross-Origin Resource Sharing. And I don't want to open the door on this today, but it is a security mechanism built into the browser and part of how most web servers, including Flask, work, where not just like any IP address can request information, especially if, like in our diagram here, one server is giving us the HTML and the JavaScript, but then we're talking to another, right? Because the risk is that someone malicious somehow gets in the middle and like steals my bank password or something. And we'll talk more about CORS later. It's always a little trippy for me, but the good news is there's an easy fix to this. And what we need to do is in our Python code, we are going to, in fact, install a library called Flask CORS that makes it easy for Flask to accept requests from any origin. And this is really just for development purposes and local development purposes. When we're in a production environment, there are some other security related concerns, but for local development, this is a pretty normal process. And there are ways to then configure the different rules. So I need to install it with pip, and then it's pretty easy to use. And in fact, I'm going to double check my guide code too to make sure that I'm using it the easiest possible way. And so from this library, we're going to import this cores class. And we are just going to pass our Flask app into it. And this opens our Flask server to receive requests from all origins, including VS Code Live server. And so now, fingers crossed, the code runs. And if I go back to our program and refresh the page, we see printed out our student information. Right? And so we've successfully gotten our students. And now that we've done that, let's add them to a list. And we have here a nice container on an unordered list with the ID student list. So let's just write a function. We'll call it append student to list, and we'll take in a student object. And let's add a description here. And this takes a JSON for a student. It then creates a list item element with student info and appends it to our list of all students. And so its param is, I'm just going to call it JSON. And it doesn't actually return anything. Right? And it returns nothing. It instead, what it's doing is it's appending an element to the DOM. So now that I have my student, first, I'm just going to do a console log, which I always like to do because it helps so much with debugging. So if I just do it all the time, when I run into a bug, I don't have to add the console log. It's already there. And what I want to do is I want to create my list item. Then I want to add the student data to it. And then I want to append the list item to the UL, the unordered list, our container in the DOM. And so I'm going to go ahead and let's create our list item. And now let's modify it. And we'll modify that inner text attribute and we'll use a template literal. And we'll say student object, and let's just show the ID and the full name. And how about my student's age? And then how about my students? I think it was their grade. And I see a squiggly there, which tells me I probably have a typo. And I see a dot that's missing a property after it, and that should fix that. And so before I can append this to the DOM, I need to grab the DOM element we are going to add it to. So let's do container equals document get element by ID. And I'm going to actually just use the element inspector and poke around in here to find my unordered list with the ID of student list. I see a couple questions, and give me just a minute to finish implementing this. And I've got my container, and now let's do the appending. And so I've written this code and I'm hoping it's going to work. And now I have to actually use it. And for every student I get back that's in this list here, append them, right? So let's scroll back down here. And here, instead of console logging, let's call my append student to list function and pass in the student object data. And now we see we have our students and they get appended to the list. And so whenever I load the page, it makes that API call to get the students. It's talking to my Flask server. My Flask server is talking to my database and fetching the data from my database. And then we're creating that list item with the student data and adding it to the list. And I saw there were a couple questions. Tom, yes, sir.
Never mind. You answered it by scrolling down. I didn't know you had a second portion set up for the Pokemon demo because in the top all I saw was the Pokemon name part to your HTML. So my question was going to be is like, why is your console logging to the Pokemon index if you're not actively loading that one? So I didn't see that bottom part until after you had already done everything.
Got it. No worries. And thank you. What else is on people's minds? And what other questions do folks have? And this is really kind of our end game here, right? There's more variations that we could do on this, but we've now gone from two ways to work with promises. We saw dot then, and we're hitting the Poke API. And we do the exact same thing that we do here, down here in get students, but we're hitting our own API. And because we're using this syntactic sugar for a promise, async, await, I think it makes the code a bit cleaner. And so now we're calling our own API and adding students to the list. And so again, just to kind of recap what happens, because I think this is really good to see. The browser talks to live server sends back index.html and my JavaScript and CSS. The JavaScript starts running and it makes that HTTP request to my other server, also running on my computer, my Flask REST API server. Flask talks to our database because this is my endpoint, right, that my code is calling. And so we talk to the database, we get the students, we serialize it into JSON, we send it back to the browser. And then here in the JavaScript code, it's handled and that code is then turned in, and the JSON data is turned into DOM elements, into things that we actually render in the browser. Rick, yes, sir.
Well, you can let Tony go first. He had his hand up first.
Okay.
Don't worry, it's within scope.
Okay. Oh, thank you. Tony, yes, sir.
Yeah, I actually had a question about the cores thing that you did on there, and it brought up something from the other day. But when I did the app config in the Python, like in the Flask server, it wouldn't allow me to do it by username. I had to do like a triple / in order to access the database. Is there a reason for that? It was asking for a password, but even when we used a password, it still wouldn't let you in.
Say that one more time. What was it asking you for?
So here, I'll try to drop it on the annotation real quick. So it was at like when you do the app config through the SQL Alchemy, the database thing in the server.
Yes.
So we ended up having to put it in this format, if you can see it, because when the username was used, it was asking for a password, but I even went in there and reset the password to make sure it was right, and it still wouldn't give me access. So this is the only way I could access it. Yeah.
Over here, you had to like give your username and your password or something like that.
Correct.
I'm not sure what causes that. I'm not sure if it's how the Postgres user is configured, Maybe it's possible your Postgres user has different permissions. Um, but I mean, that's okay.
But
That's
this is
sort of what
acceptable
this
the
is
way it's
designed
done.
for, right? Is to be able to pass the Postgres username, the password if needed, um, and the host and, the port if needed, because that way I can talk to databases on any server. So I'm not sure what caused that, but there's not necessarily anything bad about it.
Okay, I just know it was common. I think there were a few people had the same problem. So
Yeah, I did hear a couple other folks mentioning that. Again, my suspicion is it might have to do with the permission levels of the Postgres user.
okay.
But worst case, again, that's not a big problem, right? Because that's kind of what this URL is for. Rick, yes, sir.
Uh, yeah, I had the same issue when I was doing mine. But my question is, maybe it's a separation of concern thing, but um, like yesterday when we were doing our exercise, um, unlike everybody else, I was building on information that I'd learned the day before, so I was running all my stuff yesterday on the Flash server, not the live server. Um, I guess my question is, why couldn't you just cut out the live server and have Flask running the API and the connection to Postgres? Is it just like a separation of concerns so that if you can figure out what the issue is, if one of the servers goes down, you know which one? Is it just like that?
Um, you mean combining live server with the Flask REST API server?
Yeah, I just running everything off of Flask. Have Flask serving the HTML and uh, contacting Postgres.
Yeah, you could do that. That was a more modern, that was a pattern that was often seen more in the past, though it's still used sometimes. The advantage of this approach becomes clear later when we're using React, because there's a lot of steps involved with React.js, and it's nice to have a separate server. Also, then this is getting a little further advanced, but in terms of kind of deploying this into a production environment for real stuff, it's kind of nice to have these servers separate. If we're Amazon and we're getting, like thousands of requests a minute, it lets us scale and manage these things in different ways.
Oh, okay. Yeah, I didn't
Yeah,
think about scaling. All right, cool.
yeah.
Yeah.
Great question. And I know I keep saying we'll see more of this when we get into React later, but when we get into React later, we'll see more of this. Though just the fact that with live server, um, whenever I modify this code, it refreshes the page is kind of awesome. And that would be behavior that's pretty difficult to get working with a Flask REST API. Though there are ways, but this is ends up being really nice. Chris, yes, sir.
Yeah, I was just thinking, since you're pulling the Pokemon and everything, can you organize that into another, like say another Flask file or something to organize it and say another dictionary and then display it? Or would that be like too overkill and you just do everything in your JS file?
Uh, do you mean taking the JavaScript code for the Pokemon and putting it in a separate JavaScript file?
That or I'm just thinking of like putting it into like how we have our students in like a dictionary on the Flask or like sorry in the I guess the database. Like, could you take the Pokemon, retrieve it from the API, and then store it and then organize it to where you can I guess like display it more, I don't know, cleanly?
I
Or
see.
would that be too much?
Um, it's not worth the effort is the short answer. You're basically saying, hey, like this JSON object we get back when I'm looking at different Pokemon is huge. Could I just grab a part of this and save it to a database and work with it that way? Um, the short answer is like the more you work with this, the more you get comfortable with this. And what really matters is where's the data coming from? Because with Poke API, right, this is really here for educational purposes, but let's say if this was really Nintendo's Pokemon API, maybe they're constantly tweaking, Charmander's power levels or whatever. So the real world data may be constantly saving. There's ways to do like caching, which is sort of what you're talking about, but that's normally done to cache data that we know doesn't change a lot or that we're going to read from a ton. It's not really worth it in terms of making it easier to work with large JSON objects. Does that help answer your question?
Yeah, that does.
Okay, awesome. Yeah, no, that's a good thought. I know the Pokemon JSON object, right? This feels like a beast, but you end up getting used to it really quickly. And actually, when I look at this, I think about how well organized this is and how nice it is. So a lot of this is just about kind of getting used to it. And that's going to be a theme as we get deeper into the course too, is just everything starts to get bigger. Our code bases get bigger, JSON gets bigger, and so on. Tom, yes, sir. And then I think we should wrap.
Kind of beating a dead horse, but also not. Going back to grabbing the data from an input field, from your form, for example. Is there any particular reason why we couldn't call it by its element ID instead?
You mean I have this input field here. I have Pokename. It gets passed into handle get Pokemon. And if I go to handle get Pokemon, do what differently here?
Yeah, so like rather than taking it and converting it into like an object, like data, etc. Like, because in this example, like you said, no matter how many data points we have in this example, a form always returns an object like object. Um, if we are doing something simple and it's just like a name and we're just using the form of a function, just the submit button functionality of it, is there any reason why we couldn't just call, like, say, the ID of that input field and assign it to a variable to grab the data? So it'd be like document dot
Yep.
get element by ID, the ID name, dot value, and assign it to a const and use it that way.
Yep. If all you have is an input field and a button and you're not using a form, you absolutely could do it that way.
Okay.
Yeah, forms, it adds an extra step. It also adds some built-in behaviors that can be kind of nice, but both ways will work.
Okay, I just didn't know if there was one particular reason why we should use one over the other, because I've seen you use that one quite often, so I just didn't know if there was, that's just the better way to do it or something.
Not really. I mean, forms do certain things. If we look at the form element, there's certain things you can do with this, like adding labels, other things that are a little bit quality of life stuff. But when we get into React, we'll see both work. All right. So we have covered a lot of ground here. We now are fetching Pokemon from Pokemon API, right? We can turn it into cards. We can render it on our DOM. And we're also fetching from our own Flask server. And so now we are 100% full stack. And as you guys have seen, we're sort of like Alice going down the rabbit hole, right? And you guys touch on some good points. There are a lot of different ways to do things. Sometimes some ways are preferred. Sometimes it doesn't make a huge difference. In general, I think doing what works makes sense. We do most of the ways where we're demoing stuff do follow best practices for a variety of reasons. But again, everything we're doing right now with manipulating DOM elements like this is really more about learning how the DOM works and how to interact with it with JavaScript. And later when we get to React.js, we'll see that it does a lot of this work for us. It introduces some new wrinkles, but some of these pain points go away. So thank you guys. I hope this was helpful, and happy coding, and have a good afternoon, everyone. And let me stop our recording.